welcome back to my channel. So today we are going to solve this question. Calculate for the figure below I, current in each resistor II, total current III, power in each resistor, and then IV, total power. So that is the figure. The figure is having R1, R2, R3 connected in parallel across a 20 volts supply. So R1 is what 5 ohms, R2 is 2 ohms, and then R3 is what 10 ohms, and is connected in parallel across a 20 volts supply. Okay, so let's solve the question. So the solution I, we have to calculate for the current in each resistor. All right, so since it's a parallel circuit or it's a parallel network, the supply voltage here, that is 20, is common to all the resistance. Okay, 20 volts will be the same voltage across resistor R3, it will be the same voltage across resistor R2, and then it will be the same voltage across resistor R1. Okay, so the supply voltage is common to the resistance. All right, so I1, that is the current flowing through resistor R1, is equal to V over R1. So V here is the supply voltage, okay, since it's common. All right, so this is equal to 20 over 5, or 20 divided by 5, and that is going to give us what? 4 amps. So I1, that is the current that is flowing through resistor R1, is equal to what? 4 amps. I2 is equal to V over R2, and that is equal to what? 20 over 2, which is going to give us what? 10 amps. So I2, that is the current flowing through resistor R2, is equal to what? 10 amps. Then I3, that is the current that is flowing through resistor R3, is also equal to what? V over R3, which is 20 over 10, or 20 divided by 10, and that is going to give us what? 2 amps. So I3, current that is flowing through resistor R3, is what? 2 amps. I hope you understand. All right, so let's move on to II, which is the total current. So the total current IT is equal to I1 plus I2 plus I3, and that is 4 plus 10 plus 2, which is going to give us what? 16 amps. So the total current is equal to what? 16 amps. I hope you understand. When we add I1 plus I2 plus I3, that is the current flowing through resistor R1, the current flowing through resistor R2, the current flowing through resistor R3. When we add them, we are supposed to get the total current. Okay, so that is what we have here. IT is equal to what? I1 plus I2 plus I3, and that gave us what? 16 amps. I hope you understand. All right, so let's move on. So III, we have to calculate what? Power in each resistance. Power in each resistance. So P1, that is the power across resistor R1, is equal to I1 times V. So the V here is the supply voltage, okay, since the voltage is common. So we have 4 times 20, which is equal to what? 80 watts. Then P2 is equal to I2, that is the current that is flowing through resistor R2, times the supply voltage V, which is equal to what? 10 times 20, which will give us what? 200 watts. And then P3 equals I3 times V, which is equal to what? 2 times 20, which is 40 watts. So P1 is 80 watts, P2 is 200 watts, and then P3 is what? 40 watts. All right, so let's do the last one, that is IV. We have to calculate for the total power. So the total power PT is equal to what? IV. I is the supply current, and then V is the supply voltage. So when you multiply the supply current by the supply voltage, it will give you what? The total power, or the supply power. Okay, all right, so this is equal to what? 16 times 20. So the supply current is what? 16, and then the supply voltage, or the total voltage, is what? 20. So when you multiply, we are going to get what? 320 watts. So the total power is equal to what? 320 watts. I hope you understand. Thank you so much for watching the video. Please subscribe to the channel, okay? Subscribe to the channel because we have a lot of calculations for you, okay? Thank you.